Okay, hello guys and welcome back. So today what we're going to be discussing is A-level computer science 9618, the new exam code that was introduced 2 years ago, and we're going to be discussing paper 1-2 of the June 2022 series. So 1 hour 30 minutes is the total time, and this exam paper is of 75. It tests the theory fundamentals of your AS level. So without further ado, let's just get straight into this. So question 1 says draw one line from each image representation term to its correct definition. Okay, so this is pretty straightforward. Yeah, so as they say, draw one line from each image representation terms to its correct definition. So first up, we've got pixel here, and you see the options, the number of pixels wide by the number of pixels high. That's not going to be a definition for pixels in itself. And you see stores data about the image file. That's also incorrect. The number of bits used to represent each color. No, it is the smallest identifiable component of an image. Yes, so an image is essentially made up of pixels, and the smallest identifiable unit or part of it is known as a pixel. Now the next one we've got is bit depth, right? So pretty self-obvious when you look at the remaining three options, and this is a 3-mark question, so this is easy 3 marks that you can score. I mean, bit depth is not going to be the number of pixels wide high by the number of pixels wide or pixels high. It's pretty straightforward. It is the number of bits used to represent each color. So bit depth is used to as they say, represent each color, and is right. Meanwhile, pixel is the smallest identifiable component of your image. So image resolution, as we see, is usually you often hear a screen or a monitor is going to be 1920 by 1080. So this is pixels wide, and this is pixels high, right? It's basically width into height as you. So move this. So pretty straightforward. The number of pixels wide into the number of pixels high. That's going to be the first option. And obviously file header that we've got in the last one, it's the one that's left now is stores data about the image, the number of bits per pixels, file size, etc. It's basically all the data about your image is stored in the file header. The following section of a bitmap image is 10 pixels wide and 5 pixels high. In this example, each color is represented by letter. B is blue, so this is blue. I would assume this is yellow, this is red, this is orange, etc. The completed image can have up to 256 colors. Identify the smallest number of bits that can be used to represent each color in the complete bitmap image. Now this is usually something that confuses a lot of students, but this is one trick that was easy for me to remember when it came to questions like these, and that is you use the formula 2 to the power n to see equals to number of colors, right? And this n is represented by and this n indicates the smallest number of bits, right? So if you take it in this case, we've got 2 to the power n, that is equivalent to, no, is a different color, as they've said, 256. So what power of 2 will give you 256? In that case, n is going to be 8. So the smallest number of bits that can be used to represent a complete bitmap image in that case is going to be 8 bits. Similarly, if they had told you that instead of 256 this was 32, you would have said 2 to the power of n, n being the smallest number of bits, is equals to 32 different colors, and in that case n would have been equal to 5. If it was 64, it was 16, etc, etc. So that is one way generally you can, provided you don't mess up in the math part, that is one way you can a pretty straightforward way of getting questions like these correct. Now the next part that they usually ask for is for the file size. So calculate an estimate for the file size of the section of the bitmap image shown, giving your answer in bytes. Use your answer from part BI. That is the first part from B. So it's 10 pixels wide and 10 pixels high, and the smallest number of bits that can be used to represent each color. So our bit depth is 8, and we've got a resolution of 10 into 5. So the first part that we're going to use is, the general formula is the general formula is the number of pixels which you've got wide into number of pixels you've got high into your bit depth. So it's going to be 10 into 8 into let me just do it in order. Actually, it's going to be 10 pixels wide into 5 pixels high into your bit depth of 8, and this is going to add up to 10 into 5 is 50, 5 8 is 4, and you add another 0, so this is going to be 400, right? So this, however, is, remember, 400 bits. They've asked the answer in bytes. That's the key part. So we know the general rule: 1 byte is equals to 8 bits. So now, just taking step by step, obviously if you know the idea you can cancel the 8 out here as well, but it's important that you understand the whole process behind it. So you'll divide 400 by 8 and you'll get your answer, which is 50. So this is 50 bytes. So that is the storage size, the file size for the bitmap image they've given in the earlier part. So describe how changing the color depth of an image affects its file size. So this is a theory related question. So you're changing the color depth. How does it affect the file size? Now obviously you can answer this in two different ways. So now whether you're increasing the color depth, over here for example, if you're increasing the color depth, where are you going to take that scenario? So if you're increasing the color depth, if we increase the color depth, file size will increase, obviously, because more bits will be used to represent each color, and since more bits are being used to represent, the file size will generally be larger. File size will increase. You can write the inverse scenario as well, but you won't get your 2 marks for this. This is just for 1 mark. The second mark that you will earn, I'll mention it in bullets, is for providing the reason. So increasing the color depth will result in more bits per pixel, hence more data stored. Or you could mention and greater file size. All right, so you're going to get 1 mark for the general answer, which is going to be that obviously if you increase the color depth, the file size will increase, or vice versa. That's going to give you 1 mark. The other mark will be for the explanation. Inversely, if you were to say that if we decrease the color depth, that would be less bits per pixel, thus less data stored, and a smaller file size, right? So that was your 2 marks. So it's important in computer science P1 that you are well aware of what you need to answer to gain the full number of marks. It's very important to refer to mark schemes, especially when you're doing topic-wise questions. So when you get to full-fledged paper and yearly past papers, you have an exact idea of how and what you need to answer in questions like these. The first row of pixels in the image from part B is shown. Explain how these pixels can be compressed using lossless compression, right? So now they've specified that it is lossless compression. There are 2 compression techniques that are that you're asked to learn in the syllabus. One of them is lossless compression, as they've said. The other one is lossy compression, right? So we cannot use a lossy compression technique, which is you reduce the resolution, you can crop the image, etc., etc. So we cannot use those techniques. Now the lossless compression that you can use, and you get 1 mark for just stating this, is run length encoding. Right? So you can say you can use run length encoding, and the next mark that you will get, because this is a 2-mark question, will be that how run length encoding will work in a sense. So it's basically going to be, it's going to count the number of times a pixel is repeated and store its integer and store it as an integer in 1 pixel. And you can mention in brackets, for example, in this case right here, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've got B that is appearing 10 times collectively. So you're going to mention over here, it's going to be stored as 10B. Similarly, if I were to have a row where you had R, 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 and then B, 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 then that pixel would be stored as 3R, 3B. And then you can add white as well, WW. And if I were to do them one by one, then this becomes 2W. And if I were to say, this is just an example, and if I were to say violet and orange, then you would say 1V, 1O. And this is the premise of run length encoding, a compression technique used. So we got 2 marks for 1 mark just for stating the technique used under lossless compression, which was run length encoding, and another mark for just explaining it, right? And the grammar is not really weighted that much. As long as you're making sense to the examiner, you'll get that other mark as well, right? So now moving on to question 2, we got up the pace up a bit. A car has several features. One feature is a lane detection system. The system monitors the lines on either side of the lane. If the car gets too close to one line, the system automatically moves the car away from the line. So it's got a lane detection system, and they've described it briefly of how this system functions. Explain why the lane detection system is an example of an embedded system. Now this is one of those real life type questions that they have started to give out a lot in 9618. And the thing is, right, it's just general knowledge basically. So an embedded system is entirely built to perform a specific task. You might see them in you might know them as microprocessors, and you see them in your washing machines, your alarms, and other devices that entirely have just one specific purpose. So general description of them is they usually have a specific role. They cannot really be modified. You cannot really change or update the microprocessor that's fit into your washing machine or an oven. It's durable and it does its job for as long as you want it to, and it does a specific task, and you know, it's a built-in microprocessor, right? So that's pretty much what we have to describe over here. They've explained why lane detection is an example of an embedded system. You just have to describe the features of an embedded system. So it's 2 marks. I'm actually going to give you 3 things that I just iterated right now. First and foremost, it's got a built-in microprocessor. Right? Secondly, you're looking at performs a specific task. Right? And the third one that you can mention as for why it is an embedded system is it is difficult to, or rather you can just say cannot be modified or updated. And by this I'm talking about the lane detection system updated by the owner. You know, you can update and modify your computers, your other devices, but embedded systems, they've one specific feature that is mentioned in your syllabus is that they cannot be easily updated or modified by their owners. So two other features: record the number of miles traveled in the current journey. All right, so these are two additional features the lane detection system performs. So record the number of miles in the current journey from when the engine is turned on to when it is turned off. Record the total number of miles the car has traveled since it was built. All right, so for one journey, you might see in your cars, when you can press a few buttons, it gives you different distances. One might be for your current journey, from when the car has been turned off to when it's next turned on to when it's next turned off, pardon me. And the one might be for the total lifespan of your car. You might see it might be 100,000 kilometers, might be thousands of kilometers. So that's essentially what this lane detection system is doing as well, right? So identify the data that will be stored in the primary and secondary storage of the car of these two features, right? So we have to deduce which of these features. It's a general knowledge question, not specific to computing as well, but that's just what the examiner likes nowadays, I guess. So which one of these is going to be stored in the primary and secondary storage of the car for these two features, right? So primary storage is the storage that you will need to access live and during time, right? So that's when you have to say for the current journey, you need to access it and you need to constantly update it while the journey is going on. And for the secondary journey, you can access it on and off as well. So for the secondary journey, you can say the total mile was traveled. Total miles traveled since the car was built. The car has a resistive touchscreen for the user to select options. Resistive touchscreen for the user to select options. Tick one box to show whether each statement about a resistive touchscreen is true or false. Now again, this is just purely down to you being able to consistently recall learning outcomes from their syllabus, especially when it comes to these dry chapters on input and output devices and the latest technologies and whatnot. You either know about this or you don't. There is nothing in between. So that's just one thing about this paper. You're gonna have to consistently recall. You're gonna have to consistently practice, and you can sometimes rote learn a few things in this exam, because there are parts of it that test your concepts, and we'll get to those questions. But topics like these are just, you'll have to rote learn them, you'll have to memorize them, you'll have to recall, you'll have to refer to your sources consistently, otherwise you will start forgetting them. And you'll have to and do refer to the mark schemes as well. Mark schemes are a good way to memorize. The books can be a bit of a monotonous source and can be a bit difficult to take information from. The mark schemes are very good sources, so do practice questions and do refer to mark schemes for answers. So yeah, so the screen has always has 5 different layers is the first statement, and that is false. A processor determines the horizontal and vertical coordinates of the point of contact. So yes, that is true for a touch screen as I am using right now. The moment my pencil does touch a certain point, what the processor does is it registers the horizontal and vertical components, and that is used, and the point of intersection of that is basically used to register a touch, and that is what you use to navigate your way through touchscreen devices, right? The touchscreen will work if any object touches the screen. That is also true. So, and they gave you 1 mark for this, which is, I don't know what to say, to be honest. All right, so question 3. The table shows part and instruction set of a processor. The processor has one general purpose register, the accumulator, and here they've given you the table with the opcodes, the operands, and the explanations. So you don't have to memorize them. That's a common misconception a few students have. You will always be provided this table in your exam whenever you'll be given a question regarding assembly language. So do not worry, you just need to be familiar with how to use these certain opcodes and operands, right? And this type of variation that they brought in used to be rarely seen in the older formats, 9608, but in the newer papers, this has been a very frequently tested type of questions. Okay. The accumulator currently contains the following positive binary integer. They've got this down. All right, write the bit manipulation instruction that would change the binary integer in the accumulator to this, right? All right, so if you look at this, you've got right here, you've got your ones, zeros, 1 0 0. You've got this positive binary integer in the accumulator, and you've changed it to the point where you've got every single one of them as 1, right? So a bit of common sense would have you that for all of that to happen, you would need to do, you can't use an AND operation, because then you would need all of the above. And essentially is used, it would take a product, right? So unless you've got 1 and 1 here, the change would not occur, it would not be 1. So what we can use, however, is we can use OR, because if I add all ones here, for example, just to illustrate, as long as I have one of these opcodes with 1, the addition is going to take place. We know 0 plus 1 is 1, right? And OR only requires you to have one of them with 1. So that's why it's a bit difficult to explain over words, but if you're familiar with Boolean algebra and Boolean language, then you'll perhaps get it. So for this, what we're going to use is, you're going to use OR, that's certain. But what is going to be your operand? That's the question. So you want all of them to be 1s. That way, 1 plus 1, 1 or is addition. So 1 plus 1 is going to be 1. You want this to be 1, you want this to be 1, but this to be 1, this to be 1, this to be 1. So you add all of this up. So when you add all these 8 bits up, you reach 255. There you go. The accumulator currently contains the following positive binary integer. Okay, so next part, so they've given you 0, they've given you 1, 1, and this is basically the positive binary integer that they've given us. Write bit manipulation instruction that would change the binary integer in the accumulator to this. All right, so as you can see right here, they have essentially flipped this. You've gone from this 0, this 0 has become 1, this 1 has become 0, this has become, so you're essentially flipping them. Now that is interesting. How do you get across this, right? You can't use AND, because if you were to use AND, then 0 and 0, or in 0's case, you can't use AND, because then this would have to be 0. We can't use AND, so we can't use OR, as we've seen. So by the virtue of just elimination, we're able to reach that is going to be a XOR, right? But what will be the operand for this? Now that's interesting. You see here, if we add, what we're seeing is we're going from 1s to 0s, and we're going from 0s to 1, right? So when we've got a 0, if we have a 1 with it, it's going to become 1. But if we've got 1, we need to become 0. Now, as you know, the premise of a XOR gate is that if you've got 1 and 1, it'll become 0. If you've got 0 and 1, it'll become 1. If you've got 1 and 1 as your inputs, if you've got 1 and 0 as your inputs, the output will be 1. So if we're getting to a point where to reach this from this, it's pretty straightforward that a XOR gate with every single input as 1s would do through bit manipulation. And you can work this out as well. You see, this 1 and 1, let's just dry run through this. This 1 and 1 is going to give you 0, as we've stated. A 0 and 1 as inputs would give you as 1. A 1 and 1 as inputs would give you 0. A 0 and 1 as inputs would give you 1. A 0 and 1 as inputs would give you 1. A 1 and 1 would give you 0. Another 1 and 1 would give you 0. A 0 and 1 would give you 1. So by that conclusion, a XOR opcode with an operand of 255, just as we did with OR, gets us the right answer. So these were, I'd say, difficult questions, right? but you've got to practice all of these types of questions. The more you practice them, the more you'll be. Always remember, in case of OR, you're going to be doing Boolean addition. In case of XOR, you're going to be looking at it and saying what you've got as your inputs, 1 or 0. The output's going to be 1, 1 and 1, the output's going to be 0. And in case of AND, it's going to be basically multiplication, right? All right. Now, convert the following positive binary integer into hexadecimal. So the following positive binary integer into hexadecimal, right? So we're converting from binary into hexadecimal. That is pretty straightforward. So for hexadecimal, the trick is you just split it. So you've got 1, 2, 3, 4. Just split these two because you're going to be doing it from, okay, and just mark them down. 1, 2, 4, 8. What is this giving us? 2 plus 4 is 6. 6 plus 8, this is giving me 14. So if it exceeds 9, that means it's going to be an alphabet. If it's from 0 to 9, it's going to be an integer. Well, you look at here, 1, 2, 4, 8, mark them down. You've got 1 plus 2, that's 3, 3 plus 4, that is 7. So this is giving me 7, this is giving me 14. Now, as I said, if it is exceeding 9, that means it's going to be an alphabet. So 10 gives you A, 11 gives you B, 12 gives you C, 13 gives you D, 14 gives you E. So that means that this is going to be 7E. Very simple question that I tried to go a lot more in depth to. A three-place logical shift to the left is performed. So a logical shift to the left is performed on the following positive binary integer. All right. So this is the binary integer and we've done a logical place shift to the left. Okay, that's interesting. So if you're doing a logical place shift to the left, that means you're adding 3 zeros to the right. So you're removing this, and I'm going to show you this. You're essentially just removing this. I'm just going to use white color, and you're left with this now. But again, it's got to be 8 bits. So you're going to complete the right hand side just by adding the zeros. So that's what your answer is going to be, right? And I'm going to bring back here, right? So that's what we're going to do. So just remove this. Let's remove this first. And let's just write these down. So you've got 0 and it's tetra 1. And so we've got 5 bits. We need to add 3 more zeros. And that'll be your answer. And that is essentially how you do it. So you do the same if it was a logical shift to the right. If you're doing it a logical shift to the right, you're adding zeros from the left. It's an opposite. If you're a logical shift to the left, you add zeros to the right. Oh, pardon me. I'm so sorry for that. Oh, I've got it mixed up. I'm very sorry for that. Just did a 3-place shift to the left, right? So got it all wrong, got it mixed up. I'm very sorry for that. Apologies. So what you're doing is you're shifting all of this to the left. You're shifting this entire thing to the left. That means you're going to add zeros from the right. So yes, that logic that I was telling you about, a logical shift to the left means you add zeros from the right, and logical shift to the right, you add zeros from the left. That is why I was able to use to catch out my mistake. Apologies for that. So basically what we're going to do is you're moving everything, you're moving 3 places to the left. So an outcome of that means is that you're going to be removing these, right? These. Okay. 3-place logical shift. To the left. So I'm going to be adding, you're going to remove this, and you're going to be left with this. So let's just write these two. 1, 2, 3, 4, this 0, and then you're going to add the zeros to the right. There you go. I'm very sorry for that confusion. Apologies for that. So again, To summarize once again, a 3-place logical shift to the left means that you will be adding zeros from the right, which is exactly what we did. A logical shift to the right hand side means you will be adding zeros from the left. So I'm just going to add here, add 3 zeros to right hand side. This is the first thing you're going to do. The second thing is remove 3 of leftmost bits, or also known as most significant bits. Right. Convert the denary numbers 127 and 12 to 8-bit binary and then perform the subtraction 12 minus 127. All right. So this is a 3-mark question, and they've asked us to do quite a few things in this, right? So first and foremost, you're gonna have to show 127. Now 127 is the largest positive binary number that can be represented in 2's complements. So that's just, since we've got 8 bits, the leftmost bit is going to be turned off, so it's going to be 0, and the rest is going to be 1 1 1 1 1. So 1 2 3 4 5 6 7 8. You got 1 mark for this. Now as for 12, it's pretty straightforward what you're going to do. For 12, you're going to say, you're just going to turn on the bits that represent 4 and 8. So this is going to be 0, this is 1, this is going to be 0, this represents 2, this is going to be 1 because it represents 4, and this is going to be 1 that represents 4. And the remaining are going to be 0. 1 2 3 4. And the next part that they've asked us is to do a binary subtraction. So I'm just going to copy these two. Copy, have them pasted here. Copy. Pasted. Let me just enlarge it. Yep, there you go. We're going to do a binary subtraction for this. This is the second mark that you're going to get. The third mark is going to be for this. All right. Okay, so 0 minus 1, you cannot do this. You're going to have to borrow. So you look at this, you say 0 minus 1. You cannot, you have to borrow again. So you borrow from here. I'm going to use a different color for this. Borrow from here, this becomes 0. Right, this becomes 10, right? So since this is the rightmost bit is also borrowing, this also borrows. So this becomes 10. This becomes 1. So 10 minus 1, you get 1 here, right? And 1 minus 1, you'll get 0. Since this is 0 minus 1, you 10. Pardon me, you'll borrow from this one now, this one, and this is going to become 0. It's going to become 10. It's going to become 1. And now since this is, you're going to have to borrow from this, and this is going to borrow from this, and this is going to borrow from this, and that borrowing cycle repeats. And if you apply the same steps we did for these 3 bits, you're going to end up with your answer. And I'm just going to write the answer now, 1 1, and this is going to be 1000. So the final answer that I'm just going to write here, if you follow the steps for your binary subtraction, that was 1 0 0 1 1 0 1. A school stores personal data about its staff and students on its computer system. Explain why the school needs to keep both its data, why the school needs to keep both its data and computer systems secured from unauthorized access. This is a general question. Why it needs to keep its data secure from unauthorized access? Pretty straightforward, you know. For the data, you can say that 1, the data is confidential information. And even if it isn't confidential information, someone can amend it. Amend or delete it. Right? So 1 mark for each of them. Now for the computer system, if an unauthorized user gets access to the school computer system, they could install malware on it, cause physical damage, anything that makes sense in theory, you'll get your mark. Like it's just a general knowledge question. So complete the table by identifying 2 security threats to the data on a computer and a possible prevention method. So this is a 6-mark question now, right? So you've got 2 security threats to the data on a computer. So in the first part, we answered why it needs to be protected. Now we're going to give you the possible security threats that you could have, right? So the first one is virus could be installed on the computer, and in that case you'd say, and you have to describe a virus now. So virus is a malicious computer program downloaded from the internet. It can be downloaded from the internet, it can be from a corrupt USB or an external device, downloaded onto the computer will corrupt files and it can slow down the performance of the system. Right? And ways to prevent it: use antivirus utility software. Now another threat that the program could potentially face is from a hacker, right? And that hacker could tamper with the data. Excuse my writing if it's a bit difficult to comprehend. Could tamper with the data, and you can say you just have to mention one of these. I'm mentioning more and more just for your case. Could delete the data, and anything else. So a way prevention method would be you can mention here 2-factor authentication, if you're using 2-factor authentication, whether that be through a password, whether that be through biometrics, something, then it can limit the number of unauthorized users from accessing sensitive data. Data is encrypted when it is transmitted within the school network or externally, such as over the internet. Describe what is meant by encryption and explain why it is used. So it's a 2-mark question. 1 mark will be for describing encryption. Encryption is a technique used to make a message unintelligible or difficult unintelligible. That's just the word you should use. It is the technical term, right? And why it is used? To prevent unauthorized personnel from accessing or gaining access to sensitive information. And the specifics behind how this process works is something you learned in your A2 level for your paper 3 theory. The workings behind how data is encrypted in the security chapter. But for AS, you should just be familiar that encryption is a technique used to make a message unintelligible or nigh on impossible to decipher, and it's pretty much used, when you're communicating through your apps like WhatsApp. The messages are encrypted, so the only people who can really see those messages are the people that are communicating with each other. A third party or an unauthorized user, a hacker, cannot directly access that message unless that hacker has capabilities to decrypt that message. He or she cannot decipher what is being communicated between the two users. Moving on to question number 5. A database films stores information about films and actors. Part of the database is shown. So you've got actor ID. So you've got, so they've given us, so there is a table called actor, there's a film fact table, and there's a film actor table, and these are the primary keys that I'm going to highlight using green color. So these are the primary keys. All right, so complete the entity relation diagram for this, right? So the trick in this is that the table which has the primary keys of the other tables, you're gonna draw an arrow from that, right? So it's a one-to-many relationship between film actor and film fact. So you're gonna draw a relationship like this, draw another one like this, and since film actor has the primary keys, these are the primary keys, by the way, of actor and film, that means the arrow is going to be from the film pertain. So it's a one-to-many relationship, right? And there is no such relationship between the table actor and film fact. They've got completely different groups of data. There is no such relationship. So this is a trick that you can use for these questions. No need to delve into the idea of, for one film there are many actors, or for one film actor there are many, etc. Just look at it and say, you've got your film actor film, they've got the actor ID, they've got the film ID, which are the primary keys of both actor and film fact. So thus the relationship between these tables is going to be, the arrow is going to go from the film actor table towards the actor table, and from the film actor table towards film fact table. That's all. A composite primary key consists of two or more attributes that together form the primary key. So we've got a composite primary key all right, two or more key. Explain why the table film actor has a composite primary key. Right, so this is some of the database theory that you're gonna have to memorize, and I'll just note down what is being mentioned in the mark scheme. So the first thing that is being mentioned in the mark scheme is that basically the neither key uniquely identifies each tuple by itself. And the second one being the reason, again, it's just you use this common sense. So one actor can appear in the same film twice, right? So you've got a film, whatever film it is, that actor is going to come in it once. You're not going to have a film, The Wolf of Wall Street, with Leonardo DiCaprio appearing twice in it. That's just not going to happen. Cillian Murphy is not going to appear twice in Oppenheimer, which is coming out. So That's the common thing. So one actor, and to prevent that from being represented in the table, that's why they're using a composite primary key. So one actor cannot appear, you're just going to mention this exactly, cannot appear. One actor can appear in two different films, but they cannot appear in the same film twice. Cannot appear in the same film twice. So together, they are unique. There you go. And we've just got a few questions left in this example. So right, so the next part is about the structured query language. So complete the SQL script to return IDs of all the actors in the film with the title Cinderella. All right, so we're returning IDs of all the actors, so we're returning actor IDs, right? But since we're of all the actors in the film with the title Cinderella, so now you cannot make that mistake of just referencing one table. So they've stated here we need the IDs of the actors. So for this, it's quite obvious we're gonna have to refer the actor table, right? But where are you gonna find the film with the title Cinderella? You're gonna find this in the film fact table. Film fact table. So you're referencing two different tables, and that has a bit of a more complex SQL than when you're just referencing one table. And since they've already used inner join, I prefer using the other method, which is using dots. But inner join, since they've given us, that's what we're gonna have to do with. You must be familiar with both of these methods, right? The method I prefer using is you constantly refer to it using the table, using the field dot table name, field dot table name, and that is acceptable as well. But since they've used inner join, so you're selecting, remember we have to return the IDs of the actors. So what's the name of the field? So we're selecting actor ID, and we're going to be doing that from we're going to be selecting the actor ID, and we're going to be selecting that from film underscore actor, and we're going to inner join it. Inner join means we're going to reference another table as well. So what's the other table that we're going to reference? That is going to be film fact. So film underscore fact. So since we're using inner join, we won't have to reference it using the dot. On film underscore fact dot ID. So it was pretty obvious that since they've used film underscore fact here from that table, you're gonna have to inner join it here as well. Because it's not been mentioned anywhere above. You've mentioned film underscore actor here, but since film underscore fact hasn't been mentioned, you're gonna have to mention it over here, right? That's just one way. Even if you're not entirely familiar with SQL, you can use a bit of deduction techniques to see what you need to fill out. On film underscore factor ID equals to, this is where you're gonna have to reference that the data in both the tables is the same. So film underscore fact dot film ID is equals to film underscore actor dot film ID, remember? So film underscore fact has got the film ID as well, and film underscore actor has also got the film ID. So that's what we're using. Remember we're inner joining film underscore actor and film underscore film actor and film fact tables, right? So once we've inner joined them, we're saying on the data where film fact with the field film ID is equals to film actor with the field film ID, we're gonna have the title of Cinderella. So I'll say film ID And now they've said where film underscore fact film, why do I keep saying underscore, film fact or film title, and this is going to be equals to Cinderella. Do you remember to use inverted commas for this, because you are quoting a specific text. Write an SQL script to count the number of films that were released in January. So first we were returning, now we're going to be counting, right? So we were first returning, now we're going to be counting. So what are we counting exactly, Part? Yeah, so they said count the number of films that were released in January 22. So we can count the film ID, if you ask me. And that's what we're going to use, because film ID is unique. So each film has a specific film ID. So they're not asking us which name of the film. They're just asking how many films. So if we can just take out or select the film ID of a certain film and return how many film IDs there are, then that's essentially our count. So we're going to write here, select count film ID, and you're gonna count it from film underscore from film. The spelling doesn't really matter, but it's better if you stick to whatever they've given you, right? Where, and they've said that were released in January 2022. So you cannot just use where the release date was January 2022. That's just not how it's going to work. So I'll show you exactly what you're going to have to do. So where, now release date is a table. So release date, or name of a field, pardon me, release date is, so January is obviously, as we know, it's a 31 day month, right? So you start from 1st and you end up to 32, but 1st and 31st are also there. So any day on which from the 1st to 31st that a film was released in January 2022 is acceptable for us. If it was released on the 1st of January 2022, it's acceptable. 2nd, 3rd, 4th, 5th, and so on until you reach the 31st of January 2022. It is all under the conditions that it has been asked for. So there are a few ways that you can write. So you can do it separately, and you can say where release date is greater than or equals to 01/2022, and release date was less than 31/01/2022. You can do it like that, but a more efficient way would be where release date, and I'm going to use red to highlight this, is between zero one 2022 and 31/01/2022. Okay, again, it is completely acceptable that you can use two separately, where release date was this, but you can also use between, where release date was greater than or equals to the 1st of January and release date was less than or equals to the 31st of January. That is also completely acceptable, as I stated earlier. So that's all we need to do, and don't forget to put a semicolon to close out your SQL script. So 3 marks. The first mark you're going to get is for the select part. The second mark you're going to get is for this thing, and the third mark you're going to get is for this, stating the dates from which the So E part, a database management system is used to create and manipulate the database. Complete the descriptions of the features and tools found in a DBMS using the given terms. Not all terms will be used. A DBMS provides data management. This includes development of a blank, term blank, blank. All right. So let's just dissect the passage that they've given us. Right. And take it step by step. So so they've given us all these things. We have to choose which one of these options are correct. All right. So a database management system provides data management. This includes development of a blank that stores information about the data stored. So stores information about the data stored. That means it's talking about the metadata. And the metadata is stored in the data dictionary. Such as blank blank. So there are different types of data that a data dictionary stores, and it can ask you in a 3-mark question as well. Describe the data dictionary. So it stores the metadata. That's 1 mark, as it's mentioned here, and then you have to give examples of 1 or 2 things. Now the data dictionary can store relationships. It can store your primary keys. It can store your field names, etc., etc. So, and funnily enough, that's I think what they've given us. So primary keys, field names, so that's what we're going to mention. So primary keys, it also stores relationships, it also stores along with several other things, primary keys and field names. The blank uses methods such as an entity relation diagram to show the structure of the database and its relationships. All right, so now if you look at options, it's not going to be Boolean, it's not going to be input operating, so that's got nothing to do with this structure. The structure uses methods, that doesn't work. We've used data dictionary before, interface and output. So when you come to all of this, you end up with logical schema. So that is exactly what logical schema is. Logical schema is basically you use different methods to describe the structure of a database. So there are different types of schema that you're going to have to learn. It's as part of your database theory. There is logical schema, there is external schema, and there are several others that you're going to have to be very familiar with. So in this case, the logical schema uses entity relation diagrams to show the structure of the database and the relationships in it. So like logical schema. And even if you're not aware of this being logical schema, you can perform a hit and trial method on this, and you can see that you end up with logical schema in more often than not. It's not going to be the output uses methods such as an entry relation diagram to show the structure of the database related to that. So the ability of using the options given to you and cancelling out the wrong ones can also be very useful in paper 1. The blank allows processor to perform searches to find specific data. So finding specific data, now this is one of the core features of DBMS and core reasons for using database. It can ask you why a file-based approach of storing data is not ideal when it comes to using DBMS. That is because you can perform queries. So the query processor allows a user to perform searches to find specific data. The DBMS also provides a developer blank that allows the user to create tables from. So these are all the different types of features that a DBMS provides. As we studied, it has a query processor. Now since we've also got a developer interface, we can use that to create tables, forms and reports. So that was a 6-mark question that you can easily take 3 to 4 marks out of this, and if you're aiming for an A star, you should be getting 6 and 6 out of this. I would argue that this was the most difficult part. Apart from that, it's pretty much all general knowledge. So moving on to we've got 3 questions left in this exam paper, so let's just quickly move on into this. All right, a computer uses language translators when testing a program. Describe the operation of a compiler, right? So the differences between an interpreter and compiler are something that you'll tackle in paper 3 as well, and you've tackled them in paper 1 as well. So you've got to be very familiar with this. You've got to memorize all of this theory, and you've got to understand all these core differences. So in essence, what a compiler essentially does, it translates the entire source code, and it creates an error report if possible, and unless there basically checks line by line, and it sees that if there are no errors, it creates an executable file. So that's what we're going to mention here. So a compiler in role is to, it attempts to translate the entire source code. It creates an error report. If an error was found, and in the third mark you can write, if no error was found, creates an executable file. And in the next part, funnily enough, they've asked you to describe the operation of an interpreter. So you can use this basically to gauge the differences between a compiler and interpreter. Now, an interpreter, what it basically does is it reads the code and it executes as as you go on. A compiler reads through the entire code and then it translates it. An interpreter, and this is the key difference, you can use an interpreter to translate the source code, while perhaps even if it is not complete. That is one of the advantages that an interpreter has. So an interpreter reads the code, the source code, and executes it. But the difference is, if there is an error, it stops its operation. So that was 4 marks for describing both a compiler and an interpreter. Explain how a programmer can make use of a typical integrated development environment, also known as an IDE, when writing and testing a program. So when writing a program, how can you use the features of an IDE, and how can you use, when testing a program, how can you use features of an IDE? That's what they've asked. So it's 4 marks. You're going to get 2 marks for writing, 2 marks for testing. So while you're writing, you can say you've got a dynamic syntax checker. There are several features, and I'll get to them, but first let's just state the most common one down. Dynamic syntax checking prevents the programmer from making syntax errors. Right? You can also mention the fact that there is code coloring, which allows a programmer to color different types of code. If it's a selection statement, the IDE will color perhaps the if part of the code, and it will color the rest of the line of the code differently. That can make it easier to read the code. There is indentation, which makes the code again easier to read. You can use comments and obviously dynamic syntax checking and whatnot. These are a few features of an IDE that can be very helpful to the programmer when they are writing that program. Now moving on to the testing part. And obviously there are also, I'll write additionally here, syntax recommendations that just came to my mind while writing code. I've listed down 4 of them. You've got dynamic syntax checking. It uses indentation. It's got pretty coloring. I think that's the term, which colors the different types of variables. It gives you syntax recommendations. You might have seen in IDEs when you use Python or when you use Visual Basic. When you're writing down when you're calling a function, you don't have to write that function out entirely. It gives you that recommendation. You can press tab on your keyboard and it'll autocomplete the syntax. So again, it's a way for you to reduce. You might have made a mistake typing out the name of a function that you're calling in your main module, but instead you've got the IDE to take care of that. Now moving on to the testing part. So there are a few different techniques that you can use, and this is helpful to you in your paper 2 as well. So you can use single stepping, execute, code line by line, you can use breakpoints. The feature is breakpoints. To stop the code and check certain values. This used to be part of paper 2 theory, but this can still come in paper 2, it can still come in paper 1, and who knows, if the examiner is just looking to complete the 75 marks in your paper 3, they might ask this to you in paper 3 as well. They deem this as knowledge that any computer science student should be familiar with, so you can get this tested in any of the 3 written papers. Certain values, and you can also make use of a report window to see how variables change. Go. So all right, so we've got all right. So now moving on to question 7. They haven't given us a logic gate diagram, funnily enough, but they've just given us a truth table. So we touched upon the use of XOR, and we know AND is for multiplication, and we know NOT inverts. So keeping this in mind is going to be pretty straightforward. So you've got A XOR B. So remember, when you've got 0 and 0, so we can just say 0 and since it's not C, so we've got C as 0 here, so you're going to invert and you're going to say 0 and 1. Now 0 and 1, as we all know, is going to be 0, so the answer for this is going to be 0. Similarly, you've got 0 and you've got 0 XOR 0, so it's going to be 0 again, and not C, so it's going to be 0. 0 and 0 is going to be 0 again, so this is going to be 0. So the only realistic way we're going to get x to be 1 is, as you can see by now, is if we get this to be 1, and since it's a NOT, so we would expect C to be 0, so when you invert it, it becomes 1. So 1 and 1 is the only way we're going to get 1 as our output. Do we get that in any of them? We'll have to find out. So alright, so we've got one of our inputs to be 1, so 0 XOR 1 is going to be 1, and yep, that's exactly the case we've ended up getting. 1, and since it's not C, so if you invert 0, you'll get 1, and 1 into 1 will give you 1. So this is going to be 1, and again, this is going to give you 1. So let's just do the left-hand side of our expression first. So 0 XOR 1 is going to be 1, 1 XOR 0 is going to give you 1 again, 1 XOR 0 is going to give you 1 again, 1 and 1 is on a XOR is going to give you 0. That we touched upon that earlier, and the same goes for the last one. So let's just complete the ANDs. So this is a quicker way that you can actually use when tackling logic expressions. Just take one side and work on the left hand side of all the parts that they've given, and then work on the right hand side, and then work on the final product one by one. So that's a more efficient way, I find personally. I do the first two in their entirety. On once I've gauged on how to tackle the expression in a more efficient manner, you just do left hand side of all of the parts one first, right hand side of all the parts first, final answer all the parts then. Right? All right, so now not C would mean this would be 0, this would be 1, this would be 0, this would be 1, this would be 0, right? So when you look upon all that, the only one that we're getting is in this, because all the other ones we've got 0, and when you've got a 0 and an AND, it makes it work so easy. And in essence is a pretty easy, unless you've got 1 and 1, everything else is just going to be 0, so we're just going to add the zeros. And for 2 marks, that was completing this logic gate expression. Now question 8 is something that's also gotten recently added across P1 and P3. Now in P1, this is a pretty brief topic in which they only ask applications. In paper 3, when you'll appear for A2, you can be questioned about the different types, the different components of machine learning, about deep learning, their differences, how deep learning functions, about neural networks, etc. That's something for A2. For AS level, it's just asked us to describe one application of artificial intelligence. Now, this is a pretty general topic. Even if you've not gone through the learning outcomes of your syllabus, you can pretty much state it. It's a really large part of our lives nowadays. So artificial intelligence, the one that I'll say that I've interacted a lot with is, so it's 3 mark question. A lot with is, I'll mention about gaming, right? So in gaming, characters in a video game, characters are programmed to emulate players' actions. And one concept of artificial intelligence is that not only can you emulate the actions, that's something normal machines can do as well, but it's you also learn from it. That's the difference. The human brain not only can it instruct you to do something, but since, like I said, we're doing this exam paper, so for those of you guys who will be seeing this, will be learning something from this, and you'll be whatever you learn from this, you look to apply when you do similar questions like these in the future. That's what separates us from machines. A machine can perform an action, but a machine can't learn from what it did 2 weeks ago. You can learn from a video like this. Hopefully it is helpful to you at all. And you can apply it in the future. That machine can. So the premise of artificial intelligence is now you'll be getting machines to do both actions and learn from previous experiences and adapt. So when you are playing video games, I like to play a lot of FIFA. The opposition watches you play that pass. The opposition then adjusts their position accordingly, and they try to tackle that ball away from you. When they see that you're going to take a shot, the goalkeeper positions himself or herself to try and save it. And when they've got the ball and they see you in a certain position, they adjust themselves accordingly and try to attack accordingly. That's the difference. They're not just playing the game, they're monitoring your movement, they're monitoring the player's movement, and that's resulting in them learning from previous experiences. So the 3rd mark that you're actually going to get is characters learn from experience and adapt, react accordingly to the player's action. Right? There are many different applications for artificial intelligence. It's being used in industry to manufacture cars. It's being used to assist medical professionals. It's being used as part of expert systems to provide a diagnosis. The most well-known application of artificial intelligence is now when you've got knowledge bases through ChatGPT, expert systems as they're most commonly called. So you can mention all of that in this. It's a very general knowledge question, but do be sure to read the fact that you're going to have to mention about 3 different things. 1, an application. 2, its brief premise, just summarize it as we've mentioned, and 3, how it's different from an actual machine, right? Which is what we did in part 3. So now the final question of this exam, and it's quite a lengthy one. It's on networks, which is not a topic I really fancy, to be honest, but it is part of your syllabus. So now, and it's worth a whopping 11 marks, so you cannot just leave this. The following table, the following incomplete table contains 4 network devices and their descriptions. Complete the table by writing the missing devices and missing descriptions. So the name of a device receives and sends data between 2 networks operating on the same protocol. This is pretty straightforward. Remember, receives and sends data. So receives and sends data. What is it doing? It is routing data. That's where routing. It is giving data one way, and the data that is coming to your network is so that's the work of a router. And we've got wireless network interference card. So you can wireless network interference card, it's basically a card used by the systems to allow them to connect wirelessly to a network. So you have to mention wireless in this. If you just say network, you're not going to get the mark, right? Because they have mentioned wireless. Just for a network, that would be NIC. So it's a hardware component, and all of our phones have it, all of our tablets have it, all of our devices have it. Hardware component that allows a device to connect to a wireless network. It's for 1 mark, so you don't have to give a very lengthy explanation. Just keep it brief and concise. Third part, restore the digital signal so that it can be transmitted over great distances. So it restores the digital signal so that it can be transmitted. This is the work of a repeater, as the name suggests. All right, wireless access point. So you have a lot of these in public places, right? You have in big areas where there's a central network and you've got different wireless access points. So the entire purpose of a wireless access point is that it provides radio communication from the central device to nodes on the network. It's getting quite late now. Full device to the nodes on the network. Right. Describe 3 differences between fiber optic and copper cables. So 3 differences, 3 marks. You don't have to be very lengthy with your descriptions. The easiest one is fiber optics offer greater bandwidth. Fiber optics, let's just say the difference. Fiber optics, data is transmitted through light, and photon data transmitted through photons. Copper cable, you use electrical signals to transmit it. Fiber optic is more secure, it has faster data transmission, it can be used over longer distances, and there are many different types of things. It is fiber optic is more secure, and I'll just add a fourth one. Fiber optic. So we'll try to complete this within the time limit. Can be used over longer distances. Alright, so now the final part of this exam paper is describing CSMA, or carrier sense multiple access, or collision detection. Now this used to be part of your paper 3 theory, but now it's been transferred over after the 9618 over introduction. Now it's a part of 9618 networks theory. So this is something that I just recommend you learn, and you just pick 4 points up from your mark scheme and you just memorize it. But I will explain its reasoning behind and why it's so important in networks as well. But you can save your hassle and just put a few minutes in and just memorize it and just give it out. The examiner's not going to award you any brownie points for actually trying to become a network engineer. So the entire premise behind how carrier sense multiple access works is you've got a workstation that listens to a communication channel, and the data is basically only sent when the channel is free. Now at the same time, there are multiple workstations connected to a single channel, so they might send data on at the same time. Now in that case, because they've sent it to the same channel at the same time, a collision might occur. Now in that case, if a collision occurs, a jamming signal is sent and transmission is stopped. And once that has happened, both of the workstation basically waits a random amount of time before sending data again, right? And that in essence is just carrier sense multiple access. So I've explained it to you for a 5-mark question. Now let's just write it. So a workstation listens to the communication channel, and this is exactly how it's been mentioned in the mark scheme as well. Communication channel data is only transmitted when channel is free. Two workstations listening to the same channel might transmit data at the same time, this causes a collision and the workstations send a jamming signal to halt transmission each wait a random amount of time before trying to resend. So this is basically the system used in Ethernet and in an Ethernet. Resend data. So quickly to summarize in just in a few seconds, a workstation is basically listening to a channel. Data is only sent when the channel is free. Now sometimes, since there are multiple workstations connected to a channel, they might send it out at the same time. A collision does occur. Now once a collision does occur, that's where this collision detection mechanism actually starts working. So the workstation then send a jamming signal which halts transmission, and they both wait a random amount of time. The keyword is random amount of time, and then they attempt to resend the data. So that is 5 marks. This is actually going to get you 5 marks. You only need to mention 4 of these, but I'd recommend you to understand and learn all 5 of these. So that concludes this exam paper, if I'm not wrong. Yes, it does. And I don't think there were any difficult questions in this. You can probably say SQL. I mean, it did have a level of greater difficulty. Let's say the bit manipulation thing was quite a bit challenging, I'd say, but it can easily be you can gain marks from it with more and more practice. So, and apart from that, rest of the paper is just like always. It's about recalling information through your book or any notes you use, and just practicing topic-wise questions. The more you recall information in paper 1, the more you're going to retain it, and the easier it's going to be. A lot of these questions are black and white. You either know their theory or you don't. There is nothing in between. A lot of them are general knowledge questions, so it does involve quite a bit of rote learning and quite a bit of memorization. So be sure to do that, and be sure to consistently practice topic-wise questions. And once your syllabus has been completed and you edge closer to your exams, you start practicing a yearly past paper. So that will conclude this. I'll hope to see you guys next time. Thank you for watching.